Hello and namaste everyone. I would like to thank you all for attending today. My name is Bikash Pokhrel and I'm a PhD candidate at Auckland University of Technology in Auckland, New Zealand. The topic of my presentation today is investigating a business case framework for the Nepalese government agencies to understand the significance of cloud computing for improved e-government services. Your questions about this presentation are valuable for my research, so I request you to keep them until I finish this brief presentation. So this is the outline of my presentation today. I will share the most common e-government challenges, a simple comparison of on-premises and cloud computing, and some sections of the e-government cloud adoption framework that is used to perform business case development in the context of Inland Revenue Department of Nepal. Well, talking about e-government challenges in Nepal, I did the systematic literature review of 57 relevant academic articles related to Nepal and other developing countries, those published between 2005 and 2020. The three most common challenges identified from the review are: number one, limited access to the ICT infrastructure; number two is increasing ICT budget required for upgrading and maintaining computing resources; and number three is the lack of ICT technical human resources to manage and maintain the services. Due to these challenges in developing countries like Nepal, e-government success model deployed in a developed country may not exactly apply to the context. So, an independent research could be more relevant for the knowledge contribution. Cloud computing is quite famous as an enterprise solution these days. Can cloud be a solution to minimize these e-government challenges? If yes, how? Currently, mostly the e-government system in Nepal are on-premises. A simple example of on-premise infrastructure is building our own data center by guessing how much peak load might be. If the design couldn't handle the load during the peak demand, then we suffer. Or if the infrastructure we have exceeds the demand, then we end up paying for the resources that we really don't need. In cloud computing, instead of designing our own data center, we end up having all the resources and application for our data center through the internet with the flexibility of increasing or decreasing the resources according to the demand. This is a common comparison used between on-premises and cloud computing. In case of on-premises, much of the system complexities like implementation, people, maintenance and training are hidden under the tip of the iceberg, and they are to be managed by the users. Items to be managed by the users are related to the current e-government challenges I discussed earlier. However, with the cloud computing, on the other hand, transfers all this complexity to the vendor. And of course, that doesn't come for free. It has higher subscription fees. These are all vendors' explanations for selling their product. However, the government context is different. They have several complexity and sensitivity. So this may not sound as simple as discussed. The framework I'm talking about is all about enabling the government agencies to identify their real need, not depending on the vendor forecast. And to have the fair comparison of on-premises and cloud subscription cost. Let me jump into the outline of the framework. The framework answers what do you have currently and how much you pay for it. Is cloud feasible? What are the opportunities in the context of cloud? Moving on to the first stage of business case development, a tool is developed as a part of this framework to capture the existing infrastructure. This tool can have several tabs in Excel format, and it is made simple to understand for the user. The first tab is the instructions for the users regarding the tool. Second tab is for the servers and the cost. Following tabs for software applications, end user device, data center, other resources, and human resources. This automated tool gives the final summary of the on-premise total cost of ownership. Moving on to the second step is the identification of the cloud opportunities. This tool is named as Cloud Acceptance Checker. It has altogether 11 rating questions related to scalability and elasticity, financial capability, skills and infrastructure demand, adaptability, security, service urgency, exit strategy, and interdependency in the context of the agency. The rating for each subsection with a score of 1, 2, and 3 are given and summed up to calculate the overall rating score. The score above 20 inclines towards the relevance of cloud computing. In case of IRD Nepal, the overall score obtained is 24, which relates that there is some room for the cloud adoption. Due to time limitation, I'm skipping the step 3 that basically deals with the cloud service and deployment model decisions. This is the last step of the business case development. Again, a tool similar to the one used for on-premise is used to propose the respective cloud solution for each component. A section was added to include the breakdown of cloud migration cost. This final result is again automated to the inputs in the previous tabs. The ownership costs are mainly in 2 categories: initial acquisition cost and the annual recurring cost. Naturally, with the cloud adoption, the annual recurring cost is higher than the initial acquisition cost. The cost is in USD and the on-premise hardware refresh cycle is considered for standard 48 months. All the hardware components has to be refreshed every 5 years. Hence, the initial acquisition cost for the on-premise in the year 1 and year 5 are relatively higher. However, in cloud context, year 1 is certainly higher than the following years as it has to deal with some cloud migration cost. This is the final overview of the existing on-premises and cloud adoption. This shows 15.06% of the average monthly saving with cloud adoption. We can see here that the cloud adoption can benefit the agency with the reduced IT cost. This is the part of my ongoing research. The overall comparison of the tools developed were again sent to the IRD IT staffs for the review. The feedback obtained is used to revise the framework and its tools. This will go for a few rounds of review from the experts from academia and industry before taking a final step. This is the summary of my presentation today. This research is supervised by Dr. Stephen Thorpe from AUT as a primary supervisor. That concludes my presentation today. Thank you everyone for being such a wonderful audience. A special thank to the coordinator of the session, Dr. Gyanendra Prasad Joshi, moderator Professor Devendra Thapa, and Professor Bikash Pokhrel for this opportunity. Now I am open to any questions you may have. Thank you very much.